I'm Abhishek Kumar Pandey, and we are from batch 8. Our project is MLPG. This is Shashank, Saina, and Mr. Nandu. So, this our project MLPG. This stands for Machine Learning Playground. Yeah. So our project is basically we have created a website using the powerful front-end tool JavaScript, and we have used R programming language, which is very dynamic and very applicable for machine learning and its graphs. So as a data scientist, we know there is a huge importance of machine learning in our field. Everybody must know what is machine learning and how to apply it, but we rarely know how to use it. So in our website, we have included 6 different machine learning algorithms, so that every student or any individual who wants to learn or implement these machine learning models in a project, they can directly come to our website. It has very user-friendly graphics. Anybody can interact with it, and they can know where to apply the model, how to apply the model, and know its importance. It gives a very clear meaning about the data set which you have provided and the outcome. So yeah, this is our project. So as I said, we have used JavaScript because it is very powerful tool. We handle the front end and also some of the back end with it. And the R programming, we have used R because it is very powerful tool for representing the graphs and also applying the machine learning models. Due to its diverse implementations, we have opted for these both tools. So now I would like to call Mr. Shashank to give information about our data set.
Hi, I'm Shashank. I'm here to explain about the data set from where we collected the data. We collected the data from the website superdatascience.com. Here collected the data from superdatascience.com. Here we get the data of machine learning programs and all. Our data set is comprehensive completion. We derived our data from this data set, and here we have the data, and which is clean, and they provide the clean data, and so now everyone can explore the data and technologies in our platform. This is the data set overview. This is the data set for decision trees, and this is the data set for linear regression. Linear regression means it provides the relationship between the independent and dependent variables, and this is the data set overview of the logistic regression. Logistic regression means it classifies the data and provides the data in an interactive form. And the packages we used in our platform: CA tools used for the data sets classification and other process, and Plotly is for 3D interactive and 3D plots. ggplot2 which is used for the graphical representation and graphs we used in our platform. And reshape means it is designed for reshaping and restructuring the data frames, and provides the function that is easier to implement. And readr means it is used for reading the R language and packages in the R. So now I would like to welcome the Saina.
My name is Saina, and I will discuss about the front end and the design and the coding section of our project. And this is our web page, and here you can see the navigation bar, and here you can see the models which are as displayed as cards. You can click on this model to interact with the model, and here these are all the models displayed in our card format, and this is our footer. We actually use this widget for our front end and back end, and we actually use the HTML CSS to slide our components. Coming to the linear regression, you can click on this button to open the linear regression website, and here is the data set. You can see here on the independent variable we have years experience, and the dependent variable we have salary. So what we are trying to do is we are trying to find any correlation or any relationship between these two variables, and this relationship can be established using a linear regression. You can see a linear line is drawn across the data points, which which actually signifies that there is a positive correlation between years of experience and salary. And here we have logistic regression. And when you click on this button, you will actually get a, we'll open a page, and on the page you will actually see the sample data set. So what we are trying to do is we actually take the data and we try to split the data into 80:20 ratio. 80% of the data will be trained and the 20% of the data will be tested. And we split the data set using CA tools. And here you can see the age, estimated sample, and the dependent variable, which is a categorical variable. And 0 actually indicates a person not purchasing our product, and 1 actually indicates a person purchasing our product. So what we are trying to do is, using these two independent variables, we are actually trying to predict whether the person will buy or will not buy. And here we have, on figure 1, we have no feature scaling, which means the data set, the data we used is raw. The data is used as a raw format, which is actually fed into the machine learning model. And this dotted line you see, the black color dotted line, actually indicates the 50% probability of a person buying a product. And here you can see feature scaling. Feature scaling basically normalizes our data set, and it actually makes our machine learning model more accurate. And here you can see this dotted line again represents the 50% probability of a person purchasing or not purchasing our product. And here you can actually give the input to the user, and our machine learning model will actually give us the output, required output. And here we have k-means clustering. We use k-means clustering when we have unlabeled data. So here we have age, annual income, and spending score. So what we are trying to do is we are actually trying to cluster all these data points into a unique cluster, so we can actually try to recognize any patterns and derive any meaningful insights from it. So here you can see the data is actually classified into 6 clusters, and the way we determine the optimal number of clusters is using something called as silhouette score. We use silhouette score. The higher the silhouette score is, the better the number of clusters corresponded to. And we actually have on the x-axis annual income, on the y-axis we have z-axis we have spending score, and on the y-axis we have age. And we have random forest classification. And again we have the classification problem. Here we have age and estimated salary, and we are actually trying to predict whether the person will purchase our product or they will not purchase our product. So we have again training set and test set. We actually use the model to train on our training set, and then we use the test set data, and we actually fit the data to the test set to see whether how accurate the model has performed or worse. Then we have support vector machines, and support vector machines again have age, estimated salary, and whether they purchased or not. And on the training set, we have divided our data into 80:20 ratio. Here we have estimated salary, age. We actually draw a decision boundary to separate the data into whether two clusters, whether they purchased or not. And here we have decision trees. Decision trees also used to classify a particular data point into a label. And again, there are age, estimated salary, and purchased or not. A decision tree works by splitting our data set into sub data sets, and then it uses recursion. And coming to the analysis, so relationship between age and salary. So as we have discussed before, we actually analyze the data between estimated salary and their age and their experience, and we actually found a positive correlation between those two, and predicting the likelihood of purchasing the product. So the data I showed you earlier actually comes from a mall. And we actually try to classify the mall customers into multiple clusters. And insights for decision making basically is the same. We actually use the data to classify our customers into multiple clusters, and then we actually try to better target their needs and requirements based on the demographics. And future applications and future directions, we can actually add more variables to fine-tune our machine learning model. I would like to call my friend Manikanta to give a conclusion to this PPT.
Hello, I am Manikanta. Then we later conclude the point of machine learning programming language. It is an fusion of JavaScript and R programming then we have to use that experimentally different types of databases, and we use the technologies like JavaScript for website statistics and R programming for real lifetime machine learning algorithms. And we have some tricks, different puzzle pieces tricks like logistic regressions and k-means